Good day, everyone. My name is Danny Wong, and I'm the Tech Support Engineer from SuperGIS Technical Support and Training Center. Welcome to our web course today, and today our topic is Advanced Data Visualization and Analysis. This is our agenda today, so in this lesson, we're going to go through the introduction and live demo of Advanced Data Visualization in the SuperGIS Desktop, which we will present you as the image stretch, the chart, and the symbology. Also, we're going to introduce you a live demo of the advanced data analysis in the SuperGIS Desktop, which include the topics about the spatial join, the topology, density map, data interpolation, viewshed, contour, and the NZVI. So this is going to be the part 1. We're going to show you the advanced data visualization in the SuperGIS Desktop, which the example 1 is actually the image stretch. So the image stretching in GIS, which is very important, is a very important function to get processed with the raster data, and the main function that allows user to enhance or to change the viewing of the raster images, which you can enhance the brightness, you can do some edges about the contrast, the gamma value, and also the stretching algorithm. So to enhance the appearance and to emphasize some special factor within the raster images, 4 different kinds of the stretch type has been provided with the SuperGIS Desktop, which include the minimum maximum, the histogram equalized, and the standard deviation, and also the custom-made stretching methods, which we provide some of a very useful UI interface, which you can use to do some changes about the stretching, and also you can tune the histogram with your own custom histogram settings. So let's talk about the 4 different kind of the stretch type, which is the first one is the minimum maximum. It is actually an application of the linear stretching. It automatically spreads all the pixels within the interval between the start point, which is the minimum value, and the end point, which is the maximum value, and it will provide the image with the brighter view and increase the contrast of the image. The second is actually the histogram equalized. It is actually an image contrast enforcement technology that hiding all the subtle part of an image to the light and the dark end of the spectrum. And the benefit from the histogram equalized stretch type is actually to strengthen the contrast of the images. The third one is actually the standard deviation. The standard deviation of the pixel value of each band will be calculated, and the purpose is actually to trim off all the extreme values within the pixel metric, which is a very useful function. If your raster data set have some of the extreme values, like the flashing light when we take some of the photos on the water surface or something, and so it provides a statistic linear stretching algorithm, and you can also set up the n value. So the smaller the n is, the smaller the stretch range and the greater color contrast that obtained. And if n is bigger, the result will be in the contrary. And also in the SuperGIS, which is the fourth kind of the stretch type, is the custom stretching, that user can feel free to use their own algorithm or the method to stretch the image, and you can easily adjust and apply any image stretching ways through the SuperGIS image management tools. Which now we can present you some of the result, like this is the original one, and if we do some of the which we switch the stretch type into the minimum maximum, you can find out that the image is going to be brighter and the contrast also to be enhanced. And this is the standard deviation, and all the extreme value will be trimmed off, like some of the flashing lights or the flashing value on the images, and will be trimmed off, and also the contrast will be improved. Now we're going to show you, before we move on to the example 2, well, we're going to show you how to do the strap type changing in the SuperGIS Desktop. So I'm going to switch to my demo machine here, which now you can see. This is actually the aerial photo. It's actually a satellite images you're seeing in the slides. And now to use the SuperGIS Desktop, you can simply just load in the raster data set, and you will find out that the data set is right here, and you can right click to open up the properties, which in the properties you can find the display. There's a display tab here, and also you want to change some of the transparency, the contrast or something. And also you can switch to the symbology here, which is a very important find that you can find out the stretch type here. Now it is none, and I'm going to switch it into the minimum maximum here. You can find out this, and if you want to see the histogram of the minimum maximum method, you can find out if you click this, you'll find out it will be like this. And you can also do some changes between the different band, and after that you can also do that with the custom way. So I'm now going to present you the minimum maximum here. I'm going to tap the apply button, which now you can find the image has been changed and the contrast has been enhanced. And now I can also switch to the histogram equalize, which is this one. If you apply, now you can see the contrast of the image has been enhanced significantly, and it is kind of we can simply find out all the edges of the different object out on the field. And also you can use to find out, you can also try it with our practice data. You can find out the difference between the standard deviation and the custom. You can customize your own stretching method. Now we're going to back to our slide. The example 2 is actually what we're going to tell you how to create a chart map. And to create a chart map, it's a very useful function that user can easily interpret some of the information with the chart and recognize the changes of the numbers, and also figure out some of the trend development. And in SuperGIS Desktop, we have 6 types of the built-in chart and allow user to customize their appearance, making some of the chart are more fancy and more practical, or to be more appropriate for the usage, like in the journal or in some courses. So the chart type with SuperGIS Desktop provided is actually the vertical and horizontal bar, the line, and the area, and also the scatter plot, and the box plot, and the pie plot. So this is going to be, we have provide different kind of the chart type, which you can see within these images. This is going to be the vertical and horizontal bar, and we also have the line and have the area. And this is going to be the scatter plot, the box plot, which is very useful when we are doing some of the comparison, and also the pie plot. So step to create a chart map is actually, we have few steps to create a chart map, which is very detailed, and you can also find all the steps in our help file, which is simply to be opened up. You can simply just add in all the data and open up the create graph tools and do all the settings, like setting up all the type of the graph you want to use, the source layer, and also the x and the y axis. And also you can do some setting with the axis and with all the field you want to be shown and the color. And it's very easy. And also you can create a mixed graph or an overlay graph. We're going to tell you what this is in the following slides. And you can simply just set up all the details and click finish to create the graph. So it is very useful that you can simply just open up the graph tool within the SuperGIS Desktop and hit the create graph here to open up the UI interface, user interface, to create the graph and do all the different graph settings, and you will find out that the graph will be shown in the lower part. And also you can create the mixed graph, which you can see this is a mixed graph. You can simply add in different graph and into the mixed graph, or you can make it into an overlay graphs, which is very useful to do some comparison between the different type of the graph. And also some additional properties where we allowed you to do some additional properties, which you can use the graph manager and find out all the different options that you can set up within the graph, like a color or the legend or anything you want to do some quick changes, and you can simply entering the graph manager and entering the additional properties to do some settings. So before we move on, I'm also going to show you within our demo machine. So I'm going to move on to my demo machine here. Now I'm going to switch to our here. Okay, now you can see what this is our. You can also find this all the data and SGD project file within our practice data. So to open up the chart, you can simply just right click on any blank part of the upper toolbar here, and you will find out that you can find out the graph tool here. You can simply click on it, and now you can see this is our graph tool. We have the create graph, we have the graph manager, and also you can load in the former graph. Now before we going to create the graph, we're going to tell you I'm going to show you what the data is for. So what I'm going to do now is to make some graph about all the different countries. We can see in the on the screen we have the Ireland, we have the UK, which is actually basically the same country, but I'm going to because the admin, the government is different, so I'm going to show you the different data, which have France and the Belgium here, which now you can see we have all the data here. So the region here, we have the Belgium, we have France, we have United Kingdom here, and the Ireland. So what we're going to do is actually we have different value of the population, which is here. This is actually population data, BST here, and of the different area. And also I'm going to show you in the with the admin here, I'm going to use this as the label. So what I'm going to do now is actually to start building our graph, which you can hit the create graph here. And now you can select between 6 different kind, which actually 6 different kind, because all the bar is one type and the line is one type, so it's actually 6 different type, but we split it into the vertical or the horizontal. I'm going to use the horizontal bar here and select the layer you want to use, like I'm going to use this one, countries, and select the field you want to show. I'm going to show the population here, which is here. Now you can see this is a very simple preview of our graph. And the Y field is actually optional, so you can simply, I'm going to select admin here. Okay, so now this is the admin, and also the label, I'm going to label it as admin. So now you can see the different area has been shown as the label. And also you can do some other settings. I'm going to customize the color. We provide various choice of the color, which you can use the customize. You can custom your own color, or you can use the palette here. Now you can see we have a lot of the different choices you can select between. Like I'm going to use the rainbow here. Okay, good, that's cool. And also you can match with the layer. If your layer have the different, also your layer already have the symbology setting, you can also match with the layer, which is a very convenient way to make a graph and match to the map you're building, and it's a very useful tool and very easy to use. And also the bar style here, we can select between the rectangle, the cylinder, the emboss, the light to the dark, like this one, or you want to make it very fancy like the wedge. I'm not going to use that. I'm going to use the cylinder here, which is quite rather very cool to look. And also you can select between the multiple bar type, or you want to do some size change and all the different settings. And after that, if you want to build in another chart, you can hit the new series here, that you will build in another chart that you can build the mixed graph or the overlay graph. Now I'm going to just use one and hit the next button here to do some furthermore setting, like the title of the graph, like I'm going to use graph of the, that's cool, just and the footer. And if you want to change into 3D display, which is very rather cool. You can see now the graph has changed into the 3D display, and it's very cool. And all the different settings you can set up. I'm just going to hit the finish button here. So now you can see this is our graph, and this is very cool. This is 3D 3D vertical, horizontal view of the bar. It's very cool. So this is our graph here, and if you want, you can simply just hit it. You can save, you can identify to print or export or do some of the property setting, which you can now see. It's very cool. This is a horizontal bar, and it's very cool to use. And so I'm going to shut it and head back to our slide here. Okay. So the example 3 is actually the chart in the symbology. I'm going to tell you where to, you can also set up the chart within the symbology. So the symbology within the chart within the symbology, we can classify it with the some of the type that in the symbology is actually you can do it as a chart, like a pie chart, the bar chart, and the dot density. The pie chart is very simple. It's quite like the graph, and you can show the multiple numeric field of the layer with the pie chart, and you can know the user can know the percentage or to know the comparison of the different value with the pie chart. So you will find out the pie chart setting within the symbology tab of the layer, and do some quick setting that you will be able to show all the pie chart out on the map. And also we provide the bar chart. The bar chart can present the value in the different field of the feature in the layer, and help user to do some of the contrast and attribute in the different field, which now you can see you can also find the option within the symbology tab, and it will be showing you in the following demo. And you can find out that the bar chart will be shown out on just on your map frame. And the third part is actually the dot density. The dot density represents the amount of the an attribute within the area, and each dot represents a specific number of the feature, and it's displayed with the same symbol. Which now you can see this is a very good way to show the density, like to show the density of the population or some of the different data, like a sample size, the sample counts or something, and where we also be showing you, and this is very useful. So before we move on, I'm going to switch to our demo machine and showing you this part. Right. Okay, that's back to our this demo tool. This is the same, and in this part I'm going to show you all the data within this layer, which is actually the populated places, which now you can see this is our table, which contains a lot of the different names, which is actually the populated places, which is actually much of them are the cities. And now you can see this is our population in the 1950, 55, and blah 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 blah, and you can find out that we have the estimation to the 2050. Now what we're going to do is to do some setting of the symbology here, which now the symbology within this layer, you can find out this is actually a simple symbol, which is just a point. I'm going to change it into, you can find out that we have with the point, we have the bar chart, we have the pie chart, or you can show it with a unit value. So what I'm going to do now is to show it with the bar chart. And what I'm going to do is to give it with the population data from 1980, 85, 90, 95, 2000 till 2015, which you can place it all around here, and you can change all the color if you want to change all the color. Like I'm going to give it a rainbow one, which is quite cool. And if you want to do some normalization, you can also do it, and all the properties. And now I'm going to hit the apply button, which now you can see within the different city of the area, you can find out some of the details of the different city, which this one you will find out that in the London, so the population is going to be a growth within this few year, and also with some area, and also all the symbology changes can be found around here. Now I'm going to give it back. to a simple. Okay, now let's head back to our site. You can also do other setting, like if you want to do some quick you want to do some another symbolic changes. You can find out that with this data, which is actually the polygon data, you can use the dot density, you can use the bar chart or the pie chart to do with the different data setting. Now we back to our slide. Now this is going to be the part 2 of the live demonstration. We're going to show you the advanced data analysis with the SuperGIS Desktop. Example 4, which is going to be the spatial join, which is a very useful tool to find out some of the geospatial relationship between the different raster or the vector data. So what is a spatial join? The spatial join is a typical type of the spatial analysis. At applying the spatial relationship, it's very important that we are going to find out the spatial relationship between the layers and join all the attribute data, which you can find it within the upper part of the SuperGIS Desktop. You can find out the tools, and you can find it the spatial join. It will open up the user interface. And with a spatial join, there are some of the examples we can tell you about. Like the first example is going to be the feature intersection. The feature intersection is actually what we're going to do is to find out how many restaurants in a certain area, how many, like a count or something. So a polygon layer covering an area, and a point layer which recording all the data with a restaurant, but you don't have the address, you cannot if just too many, the count is just too many, you cannot count it with your eyes. So to find out the count, you can simply just use the spatial join to intersect, and all the spatial join tool will count all the data for you, like the different count of the restaurant within the different area, which is very useful. And the second one is to find out the example is going to find we can use this spatial join to find out the closest feature. Like the question is going to be like what is the distance between each restaurant and its nearest road. So you can simply use the spatial join date tool to apply spatial join operation to find out the distance between each point featured and its closest road. You can find out exactly how close it is. It will tell you the distance, the direct distance between the like a restaurant to the road. So the resulting by creating a new layer that contains the attribute data and features correspond to the source layer and the join layer. Which now you can see that we have a lot of the different restaurants within this area and all the road data. And if we want to find out how close of each restaurant to the road, you can simply use this spatial join, and to generate the data, it will automatically count out all the distance between each restaurant to the road. And the third example is actually the overlapped feature. The question like finding out all the overlapped part of the two different river. Like we have two different river, and so each line will be given an attribute of the line that is part of, and it will help you to join the attribute data of the overlapped polygon feature of the two layers. So you can simply just find out the overlapped part of the two different layers, or two different districts. And for example, we're going to tell you how the spatial join is able to do is about the feature completely falling in another layer, which is a very useful, also been very useful function. Solving the problem like looking for the parks distribution in each town. Like we want to find out how many or what exactly the part is that falling in that each town has. So each polygon we given all the attribute of the polygon that's completely fall inside of, and you can use the spatial join this tool to join the two layer and create a new layer that the attribute include the record of the target layer and the corresponding data of the join layer. Which now you can see that if you want to find out what in which town and all the park that distribute, so you can use this tool to find out what how many and what exact the date that each park is falling in, like in the A district or in the B district. So that's before we move on, I'm also going to show you how to do the spatial join. I'm also going to switch to our demo machine here. Now what we're going to do is to switch to this sample data. What we have here is actually we have some of the butterfly survey. We do some butterfly survey in this is the northern part of the Taiwan, and this is all the city, which you can find out that we have all the city, the Taichung, the Taipei, Keelung City, the Yilan County, different county, and the city data, which is the northern part of the Taiwan. And we have here, right here, is actually a butterfly survey data, which now you can see we have a lot of different attributes within it. That we have the species, and we have the location, we have the count of the different sample. This is one record is as to be recognized as one sample site and one sample data. So it has the date, the month, year, and all the different data within it. So this is quite cool. But actually, what I can know about this data is actually which of the sample size that falls in. And also I'm really wondering that within all the cities, what is the count that I do the butterfly survey, like how many times I do it in the Taipei city, or really wondering that maybe there's no, but in the which you can simply just find out that maybe in the new Taipei city we have 3 times, but some of them are just too many, which you can find out that all the survey data is going to be 1,797 records. So this is just too much, and I really want to know the distribution of the sample size. So what I'm going to do is to use the spatial join tool, which you can find out in the tool set here. You can find out the spatial join here, tab on it. And this is the user interface of the spatial join tool. And now I'm going to switch the source layer into the northern Taiwan, because our target is to find out exactly how many sites are in each city or in each county. So I'm going to switch the source layer into the northern part of Taiwan, the polygon data, and the layer to be joined will be the butterfly survey data. And we have 2 options here, which to do the spatial join with polygon layer and point layer. So you can switch between the you can find out all the count. And also you can do some statistic, like you want to find out the sum, the average, or something. And also you can switch to this method that it will tell you that each polygon will be given all the attribute of the point that is closest to it, and the distance cell. You want to find the distance, that you can use this one, but I'm not going to find out the distance. I'm just going to find out the count. So I'm not going to select each of them. I'm just going to select just to find out the count. So I'm just going to save it and press OK here. So now you can find out that another layer has been created, which is quite the same as the northern Taiwan here. If you open up the table, you'll find out, yes, each county has been adding the count of the butterfly survey. So now I can know, my colleague has do 25 times of the butterfly survey. There have been 25 survey site in the Taichung city, and in the Keelung 0, the Taipei 0, the Yilan we do it with 18 times, which you can see that is you just can figure it out on the map, because we see that it's rather like maybe 3 times or something, but it's actually doing it as 18 times, maybe in the same place, but different time, and do some different times, different various do a lot more than within the same site, and do some various survey. So now you can see in the Hsinchu that has a lot more. That has 702, and the Central County has 465. So this is a very useful tool to find out the relationship between different layers, especially with the vector data. Now I'm going to remove this one. Okay. Now I'm going to back to our slide. So now, this is example 5. It's actually we're going to tell you about the topology analysis within the SuperGIS Desktop, which is very important function that the topology is actually the connectivity of the spatial data. It defines how spatial data share the coincident geometry and represent the spatial location as well as the spatial connectivity of the feature, which is very important and very basis of all the spatial data. And so through the SuperGIS Desktop, the topology analysis, the data from the geodatabase, which is very important, all the data had to be imported into a geodatabase like a personal geodatabase, or you can use the MS SQL or a PostgreSQL server or Oracle server, and you can simply just load out all the data, and it can be used to simulate the geometry relationship in the real world and more accurate and more close to the reality. And about the topology analysis, is actually why we need to do the topology analysis is actually the computer must understand the connectivity of the spatial relationship while digitizing the data. So it's actually quite important that after we digitize the data, we have to use the topology analysis to help us to find out all the errors or find out some of whether the sum of the spatial data is wrong or to be fixed. So with the topology, the location of the spatial data as well as the spatial connectivity relationship with all the feature is able to be represented, and you can create all the rules within the topology analysis, and different rules are designed to respectively for the point or the line or the polygon. And topology check, and it is actually very helpful for the future for the user to find out the added errors and to do corrections. Is actually the main part, or the main purpose that we use the topology analysis to do the topology check. And all the rules must be assigned and representing the errors definition. And also, you have to make sure that all the data must be saved in the geodatabase, such as the personal database of the SuperGIS Desktop, which is the same format as the Microsoft Access, MDB, or you can use the MS SQL or the Oracle or the PostgreSQL server. Now, to create the topology is very important. That before you to do the topology fixing, the topology check, and you have to start up our topology analyst within the SuperGIS Desktop and add the data from the geodatabase. And after that, you can create the topology and then do some settings and just generate the topology. And also, you will find out you can simply just add in all the topology's rules, which you can find in the properties of the topology, and add in different rules like with the line or the point or the polygon, and you can simply add in different rules you want to be in check, and after that you can simply find out all the errors that need to be fixed, which you can do the validate and the check. And the validating tool will provide 3 different kinds of the validated tool. You can drag a specific area and do the validate, or you can validate the current visible extent, or you can validate the entire topology. And we're showing you the dirty area that you can do the validation. And also we provide a topology arrow viewer, which allows you to find out to look detailed about the different topology arrows. And after you find out all the topology errors, you can also do some fixing, and we provide very quick and convenient tool to do the fixing of the topology, and also you can cleaning all the results, which you can see within the picture below, that before clean and after clean, which some of them must be separate, so you can use the rules and do some cleaning, and all the line will be separate. Now, before we move on, I'm also going to show you this part. Let's move on to our demo machine here. I'm going to switch to this one. Okay, this is actually a place within the northern Taiwan. It's a Neihu district, and what we're going to do is to turn off this a bit. What we're going to do now is to look on. This is the road of the Neihu district, which you can now see this kind of very complicated within this area. We have the highway, we have some of the road out on the mountains. So the first step we're going to do is actually to place this data, which is the road in the neighborhood, into a geodatabase, which now you can use the tool. You can find out very useful tool as the SuperGIS Data Manager here within the tools. You can click on it, and to open it, it is very like an Explorer, and you can use it. That the first step we're going to do is actually I'm going to build up a geodatabase, personal geodatabase, because I haven't got any database with me like a SQL Server or something. So what I'm going to do is to create a personal geodatabase, which is actually the MDB file, which is actually the same file format as a Microsoft Access. So what I'm going to do is actually to right click on the target folder, and you will find the new. And you can find that we can create a personal geodatabase here. You can click on it. Okay, so the name will be the new personal geodatabase, or you can change the name if you want. And what I'm going to do now is actually to import the data. To import the data, you can right click, or you can simply just drag in. I'm going to right click and select the import feature class and find the data you want to import. Like I'm going to find it in here, demo here, and this is this one, the road in the neighborhood district. I'm going to click it and hit OK button, so it will be processing complete. Okay, cool. So now you can find out. I'm going to refresh this button, and now you can find out the layer has been placed within our personal geodatabase, which is the MDB file. And I'm now also going to close this one, and I'm going to add in the data from the geodatabase, which allow me to do the topology check of this data. I'm going to load in. Simply drag and drop, or you can import. Okay, so now this is finished, that we have already placed the data from the geodatabase to our Max 10. Now what we're going to do is to open up the topology analysis, which you can find out here, the topology analysis. Hit it, and you will find out that you can't be used because you haven't turned on the edit mode. It's very important. You have to turn on the edit mode and select the data you're going to use, which is actually this one. I believe it's this one, the upper part, this one. And now you can find out the topology is empty because we haven't created anything. So what I'm going to do is to use this one, to create topology, which now we can find out, give it name of the topology. I'm going to give it as neighborhood topo. Okay, good. Now the cluster tolerance, which is very important factor that you have to know very clear of the cluster tolerance, which it will decide whether the different point or the different line to be recognized as a error or not is very important. And you can find out more detail in our books, online books here, and you can find out all the detail, all the setting, how to do the cluster tolerance within this book. And so now we're going to just to do a quick demonstration, and I'm going to select the feature class you want to join this topology. I'm going to use this one and select the. We have to export the topology into our geodatabase. So I'm going to select this one we just create as a geodatabase. Hit OK and select OK. Now you can see all the clear will be defined as a dirty area because we haven't done any validation. So what I'm going to do next is to give it some of the rows, which you can right click on the topology here and select properties. You will find out the tab that called the rows. Hit it, and you will find out there are currently just empty, no other rows within it, and you can hit the add button. Now you can find out this is a feature class we're going to build the row, and the rows will be allowed you to select into a variety of the different options. Like with the line here, I'm going to find out that I want to find out that it must not have any dangles, which actually you cannot be if a line haven't joined or haven't just fit with the another line, it will be sort as an arrow, like a dangle point. I'm going to hit OK. So now the row has been added, and when you finish it, you can simply just hit the apply button, or you can add in other rows you want, and hit OK here. So now what we're going to do is we provide three different kinds of the validation tool, which is the validation topology in the specific area. You can just drag and drop. You can drag an area and do the validation, or you can validate the current extent. Like if you're going to zoom in a bit, you can simply, like if I'm going to zoom in a bit, you can simply just validate the area within this part. Or you can, like me, I'm very I just want to do a quick validation of the entire topology, which you hit this, and it will ask you whether you want to validate the entire one. I'm going to, and you can find out that a lot of different arrows within this area, and a lot of dangle point. If you want to find out the arrows, which each arrows, you can simply use the topology arrow view here, and you can find out which you want to show, or the different value you want to show between. You can switch between different rows you've been set up. And now I'm going to show up all the arrows here and search. So you will find out there are a lot of the different arrows, and you can find out the rows and where it is. If you hit it, and you will find out that where it is will show as a little blue dot here. And also, if you want to fix it, you can simply just right click and hit the fix here, and to do like to trim it, or to extend, or to do the snap. So if I trim this one, and it would ask you to import the maximum distance. I'm going to tell, okay, it'd be cool. So this point has been trimmed off, and so you can simply just click and do the entire setting, and so you can find out there are no arrows within this part because it has been trimmed off. And so you can simply just complete the topology, and with the you can simply just move fix all the arrows, and to do a quick topology check again, to fix and check, and so you can finish all the data. Now we're going to and you can also set up different you can find all the dangles and find out all the other arrows by setting up different rows within the topology. Now we're going to back to our slide. Now this is example 6, which is actually we're going to tell you about the density map, which is actually you can simply find out the density of the different data. And the density analysis is actually represent the distribution of the quantity of some sources in an area unit. And the source data can be a point or a line layer, and a continuous raster will be generated and with the measure attribute and with the spatial distribution. And within the density map is actually we have two ways of the density analysis, which is actually the first part is the simple one, or you can do it as a kernel. The simple is actually the center of each cell as a basis, and calculate with a radius to find the source in the searching range, and multiply corresponding weight and get the sum, and divided by the certain area, and obtain the result value, which will be the cell value. And with the kernel part, it's actually disperse the node quantity of the points or the line from the center, and get the accumulation of cumulative sum of their intersection on the surface, which we'll be showing you in the following demonstration. So now you can simply just find out the difference between the simple and the kernel, which you can see this is a simple and this is a kernel. Is quite different as a result. And also, if you're applying the point density analysis, which you can find out that each point will be searched in the radius and give it a value. And we're going to do a line density analysis, which is actually using the grid cell and also the different line data, and to find out with the radius. Now, before we move on, we're going to show you actually how to operate the data with the density map, which I'm going to switch to this one. Okay, this is actually, we're going to get back with the butterfly survey here. So to apply the density map, you can simply just right click on any blank part of the upper part. You can find a toolkit, analysis called the spatial analysis. The density analysis is actually within the spatial analyst. And you can click it, and you can simply just find out that there's a function called a density here, which is generating a density map, which the input data is going to be a butterfly here, and the calculation field if you want to set up, if you want to set up or not. Like I'm going to set up with maybe count or something. And here you can switch between the simple or the kernel. Simple or the kernel. And if it's set up with the symbol here, you can simply just edit the radius you want to search or the kernel. And you can also switch between different type of the data. I'm just going to use a none here. Okay. So this is going to be, I'm just using the radius here. I'm going to set it with the 1015 and 1500. And the cell size you can decide which the detail will be this is going to be actually the system will decide for me, and I'm going to hit the OK button. So this is going to be a density map, which is not very good, and I'm going to change it a bit. I'm going to change my all the setting. I'm going to change it a bit, like I'm going to switch into the kernel here. And the radius here, you can simply just do some quick setup. I'm going to set it into 5,000 or something. And the cell size here, you can also do some quick setting. I can do it with maybe 200 or something. Hit OK. So this is more likely to be a density map. You can simply find out that maybe a lot of the different sample has been done within this site, and you can simply just try out the different setting and to find out which of the density map is good for you to do some presentation. Like a radius here, maybe you can simply just hit it with maybe 20,000, and the cell size here maybe 150. I'm going to hit it again. So this is more likely to be a density map, which maybe all the site has been condensed within this part. Okay, now we're going to also, before I move on, you can also set up the options here. If you want to, you can find out that actually the data we're using is actually like this one here. You can find out that this is a density map we generate, but if you want to make it into the shape of like a mask or something, you want to mask it with the vector file with the like a polygon there or something, you want to mask it, you can simply just find the options here. You can simply use the analysis map. You can set up like with the New Northern Taiwan or something, and you can simply just do the quick setting, and the result will be result as the shape you want to be. I'm going to remove this one and back to our slide. Now this is the example 7. This is actually we're going to tell you the data interpolation. In the data interpolation is the most field survey, or because most of the field survey or the data collection are restricted by the resource and the budget. So only some sample data could be collected, not all of them. And so the interpolation analysis will estimate the other known values by the sample data. So it is very useful, and it is suitable for analyzing rainfall and the noise and the pollution distribution, and you can simply just help the researchers or the user to find out the data they want to know. And we have two different kind of the data interpolation, two different ways. One is the IDW, which is the inverse distance weighted, and the interpolation estimate as for the unknown cell value with the combination of the linear weighted of the set of the sample point. And the weighted calculation is performed by the neighboring known value and is the inverse distance function. And so the distance of the neighboring point will influence the result. So this is actually a quick glance of the IDW function, which is this one, and we have the UI, and we're going to show you how to do this in the following demonstration. And the second part is a second way to do the data interpolation is actually the trend. You can simply find out the trend. You can simply just find out all the unknown value as a trend. So the trend simulates the trend of the spatial distribution and the original change of the geographical element. So you can simply use the trend to find out the unknown value. It calculates the mathematical curve series and displayed by the regression principles. And you can simply find out that this is actually the real value. And if you make it with the first order polynomial, you can find out the second, the third, and we have a lot of different options you can set up within the trend. So if you can like this one, I have set it the polynomial with the eighth order of the polynomial order. You can find out the trend of the sample data. Now we're going to head back to our demo machine, which is right here. Alright, now we're going to use the same data set, and you can find out we have the interpolation still the same with the spatial analysis here. The interpolation here, we have two different kind of the interpolation, which is this one is the IDW, inverse distance weighted. I'm going to hit it, and this is you can input the point like a butterfly survey, and the z-value is going to, I'm just setting none, and this is the power here. This is the power meter of the IDW, like I'm going to set it into 10. And you can also find the search radius setting. You can use the under or at least, like I'm going to search at these the number of the point, or you can set up the at least the distance you want to know, like I'm going to at least 2,500, and the cell size I'm going to not change it. So now you can find out this is not very useful, I think, because of the power meter setting. I'm going to set it up again, which is here. I'm going to switch the power to 10, and I'm going to use at least. Use the under. The point under maybe 25 or something, and the cell size I'm going to hit it with 150. So we do some calculation for me, which is this is better. So I can simply use IDW to estimate on the other part that I haven't do any of the survey. Okay, I'm going to remove it, and now I'm going to show you the trend to find out the trend of the data. So you can simply find out the trend entering the point data, and if you have the z-value, you can simply enter it. And also here, this is a very tricky part, that you can switch between various. We have 1 to 10 or 10th order of the polynomial order, like I'm going to find out today with maybe maybe 7. Okay, this is good. And the cell size here, you can simply just change it. I'm going to change it into 250 and hit OK button. So now you can find out the trend. This is actually the trend of the data, and now you can find out. And if you want to change it, I can simply just make another one, and you can do some comparison of the parameter you set up. So I'm going to set it into maybe 4. And the cell size here, I'm going to switch into 150. Hit it. Okay, so you can now see the trend that finding out is actually quite different. This is the former one, and this is this one. So you can find out the trend of the different sample size, and you can use this function to estimate the other part that we are limited to the budget that we can do some of the samples. And also you can simply just set up whether you want to match the size like a northern Taiwan, or to match some of the different shape of the other layers data, like vector data. Now I'm going to remove, and head back to our slide here. Right, this is going to be example 8. Is actually a view shed. We're going to tell you what is a view shed and how to do a view shed. The view shed is a very important function to find out which part is visible on the exact surface of the terrain. So it's a very important function that you can use the view shed to find the visible location of one or the multiple observation or observer points, or the line can be determined, like which you can find out within the picture in the lower part, that if I'm standing right here and this is the terrain data, which has the GTM data, and so on, I'm going to find out that if I'm standing right here, which part I can actually see. So you can simply just this is the elevation and distribution and the observer right here. So you can find out the view shed that if I'm standing here, this is actually the green part is actually not visible, and the light blue part is actually the visible part I can actually see when I'm standing right here. So I'm going to show you with our demo machine here. I'm going to switch to, I think it's no. Oops. Oh, I'm sorry. This one. Yeah, this one. And I'm going to remove this one. Remove. No. Okay. Good. Now I'm going to stop this one, and you can find out that this is actually the data I'm showing, and this is the district of the Neihu area in northern part of the Taipei. And I'm going to close the road here so you can see more clearly. Okay, this is actually a DTM data of the Neihu district, and which is this part is actually much higher. You can see I'm already used a stretch color, which is actually the mountain part of the Neihu district, and this is the plain part. So what I'm going to do is now to open up. I'm going to turn off the topological analysis first, and I'm going to open up the spatial analysis again. Hit it. You can find out that we have the surface analysis within the spatial analysis. So within the surface analysis, you can find out the view shed. This is the function that provides the view shed function. You can simply hit it, and you will find out that you have to you have to enter in the input surface, and also you have to enter the observer data, which is right here. We don't have it. So what I'm going to do is actually I'm going to create a point there and contain the exactly where the observer is standing in this Neihu district, and find out where the observer can actually see. So what I'm going to do is to create a new layer. It's actually to be a point, and projection. I'm going to use this one in Taiwan here. Hit it, and I'm going to just save it like this one. Okay, just a point there, and I'm going to indicate where the observer is standing within this area. So I'm going to hit the start editing button, and I'm going to add a point. Where should I add? Maybe I should add it right here. Now this is where I'm standing. That estimate where I'm standing right here, and you can simply, I'm going to save the edit and stop editing. Now this is the point where I'm standing. I'm going to change the symbology so you can simply just see more clear. I'm going to use this one, and I'm going to use this maybe like a white one. Okay, so now you can see quite clear that I'm standing right here. So now I'm going to do is to find out the view shed, the viewpoint, actually where I can see when I'm standing out on this point. So you can find the surface analysis and use to find out the view shed function. I'm going to input the surface data, the DTM, and also the observer point, which is this one, the point here. Okay, it says actually also can be a line data if you want, and also if you want to enter in multi-point, you can simply just calculate the multi-point. And the z factor, if you want to do some changes of the z factor, you can also input the parameter here and the cell size and where you want to put. I'm going to just hit OK. So now you can see that when I'm standing right here, all the green part is the part I can't see, and the light blue part is actually where I can see. And you can also tune it. That in the symbology, you can simply, if you don't want to see the part you want is not visible, I can simply delete it and hit apply. So now you can see this is the part I can actually see. And also, if you want to find out that it's more clear, you can hit it. I'm going to use it as maybe a yellow one, so you can find it rather clearly that when I'm standing right here, this is the part that I can actually see. And this is the data output. Is actually a raster data set that all the different cells in different places I can actually see when I'm standing right here. Now I'm going to remove all the data. Okay, cool. Now we're going to back to our slide. And example 9 is actually we're going to tell you how to build a contour, which is actually a very, very useful function when you want to find out some of the data and want to go to a mountain hiking or something. You can build your contour by yourself. You can simply generate it with the surface data with the SuperGIS Desktop. And so the contours are actually the lines that connect some geographic conditions or the phenomenon of the equal value, not only to be the height of the ground. It can actually also be the amount of the rains, or it can be the temperature or something. So the different kind of value has different terms, like isotherms, the isoheats, the isobars, and isolines, and you also can make more clear understanding of the surface change through the distribution of the contour. So it's very useful. And you can simply, if we have we have the elevation map, and we can build a contour map and edit, so we can have the elevation and the contour map. So this is going to be the user interface of how to build a contour. So what I'm going to do is now showing you how to build a contour. So that means that we have to back to our demo machine here. And also, you can simply find the contour function in the spatial analysis, in the surface analysis. You can find out here. We just show you the view shed, and here's the contour. You can hit it. And with the contour here, what I'm going to do, you can decide the base contour. Like within this district, is the lowest part, the mean part is actually 6, so it's been 6. And the contour interval, which is actually a very critical parameter when you're building the contour, that how dense that you want to build the contour. Like maybe I just, because the min is the 6 and the max is 520, so maybe the contour interval I'm going to set it into 20. There's quite a good range, because 10 is maybe too dense. And all the data setting you can set up and hit OK. So now you can see the contour has been built. And what I'm going to do is actually to change the symbology a bit, and so you can see more clear. I'm going to use it in the white line, which you can see this is very clear. And this is the DTM data, and we have the contour that overlap, and so you can see the how the terrain change and the distribution of the different height within the neighborhood district. And also, you can use the label function. If you want to label all the different contour, you can use the label function and show the label of the value. And also, you can change some of the text. Like I'm going to change it with maybe I think maybe yellow would be good. So I'm going to change it into yellow and a bit larger, and maybe bold. Okay. Hit apply. So now you can find out all the number where we show on the graph that indicate the different line, and you can zoom in a bit, and you will find out that all the label and be shown. And this is a very useful function that if you want to take this feature, you want to take your graph, and you can want to do the mountain hiking, you can use this function to use this contour data. So we'll be going back to our slide. So this is going to be the final example. It's final example 10. We're going to tell you about how to do the NDVI in the SuperGIS Desktop. So what is the NDVI? The NDVI is actually the normalized difference vegetation index. It's actually an index that indicates where the plantation on the ground is actually are. So it is very useful to estimate the plantation growing situation or the land cover classification. So a very useful index, and it is a very useful function that provided by the SuperGIS Desktop. So the NDVI is actually we need two different kind of the band in the spectrum. It's actually the near infrared and the red. So the NDVI will equal to the function of will be this one, and that function that you can find it within the SuperGIS toolkit that we in the data management tool, and you can find it within the raster processing. You can find the NDVI tool. So we can simply just add in with the different data to provide the NDVI value. So what I'm going to do is to switch to our demo machine again. This is our demo machine, and I'm going to switch into this one. And also I'm going to change back the stretch we're using. You can find out that this is the original one. What I'm going to do now is to demo you how to do a NDVI calculation within this satellite images. This satellite images is actually a former SAT2 that contain 4 bands, which is actually the red. The band 1 is red, band 2 is green, the band 3 is blue, and also the band 4, which is not been shown, is actually near infrared. So it contains all the parameter we need to calculate the NDVI index. So what I'm going to do is to open up the SuperGIS toolkit here. You can find out, right click and find the SuperGIS toolkit and hit it, and now you can find out that the NDVI is actually in the data management tool, raster processing. Here's the NDVI. You can hit it and you can find out that this is our tool, and you have to input some of the parameter, and the two critical parameter is actually the infrared band and the red band. So I'm going to import the infrared band, find this data, this one, this image satellite images, which is actually satellite images of the former SAT2. So we have to make sure, you have to make sure which band is what exact the spectrum is, because within the former SAT2 the band 4 is the near infrared. So I'm going to input the band 4 here, and the red band is actually band 1. So what I'm going to do is find the band 1 here, and the cell value offset and the scale of that you can simply enter in or not. It's an optional factor. What I'm going to do is to hit OK. So it's not processing and it has finished. I'm going to hit yes here. Okay, now you can see this is actually the NDVI. This is actually the NDVI of this area. So this is the original one, and this is the NDVI. So actually what it's do is to find me where all the plantation is and all the growing condition of the plantation, which if it has more leaves and more green, it will be shown in the higher value. So what I'm going to do is to change the symbology a bit and to show you what exactly the comparison of the NDVI result and the original data. So I'm going to switch the symbology here. I'm going to change the color into this one. Now actually what it's going to do is actually I can also invert it, which you can be more clear. So okay, you can see this is the NDVI value. The green part is actually the higher part is the value is higher, which is actually more green, which indicate the more greener on the satellite images. So this part should be all the plantation, and all the red part is actually not the plantation because the value is actually very low. So what I'm going to do is to tuning the display setting, the transparency here. I'm going to set it with around 50, which now you can find out what exactly comparison of the NDVI value and the original image data. Now you can find out that I have already set up the transparency, and now you can find out that all the data here, the green part is actually in the normal one is actually all the plantation, and in the red part here is actually the river and all the buildings. So it's very useful to find out to do the land surface classification and to find out the land surface land use of the area. So it can simply just help you to find out all the different, you can simply just extract all the different value that you want to find out all the plantation area within this part of the land, and you can simply just extract all the data and simply just do the quick land cover or land service, land use classification within this area. It's very useful. And if you want to change it, you can also change some of the contrast, the brightness to do some more comparison. Like I'm going to hit it with the 70, so you can find out more clear, and you can find that to be a very cool images that this part is actually all the plantation. This is the river, and with the cover or with a color, it actually indicate very good land usage or land cover classification. The land usage, the land cover, and can be showed within this kind of the different index. Now let's head back to our slide. So we're going to do a quick review that in today's web courses. In these web courses, we'll tell you the advanced how to do the advanced data visualization with the SuperGIS Desktop. We told about the image stretching, the chart, how to do a chart, and the chart in the symbology. And also we tell you how to do the advanced data analysis with the SuperGIS Desktop, which we provide some of the example of the spatial join tool, the topology analysis, the density, how to build a density map, how to do a data interpolation, and how to manage the viewshed and the contour within the spatial analysis. And also finally, we told you how to do NDVI index with the SuperGIS Desktop toolkit, and you can find it very useful and do some advanced data analysis and the setting. And you can simply also change the visualization of the different raster or the raster or the vector data set. And that will be all for today's web course. Thank you for your attention, and if you have any question, please feel free to contact us at www.supergeotech.com or to email us at staff@supergeotech.com. Thank you very much, and hoping we have to see you soon. Thank you.